is going to be the review video for Unit 2 for Algebra 2 for 2015, 2016. You should have this review at hand. Okay, I'm going to go through this with the Casio calculator. If you use TI, a lot of skills are still applicable. Verse 1, G plus F of 3a. So here's what you want to do. You want to lay out your G function, which is x squared minus x, okay, plus your F function, which is 4x. All plus means keep the same signs. So I'm going to rewrite everything. So I'm going to keep the same signs for this. So I want to combine my like terms, okay? I got x squared plus, all right, that's going to be negative 1 plus 4, okay? So negative 1, all right, negative 1 plus 4 obviously is 3, right? So 3x. Now, here's what they want you to do with that. Now that you've combined those, okay, go ahead and put 3a in that space for x, okay? So 3a squared would be 9a squared plus 3 times 3a would be 9a. So that would be your answer for that one, all right? I'm going to go ahead and here and do this, this problem right here, okay? This is a composition, okay? As you can see, the difference between this one and this one's a closed, this one's open. That's a composition. That means G of f of x. So here's where you do it. You start from this first function, okay? So I'm going to start from the G function, all right? And I'm going to put a space every spot I see x. So the x went away, there's a space. The x went away, there's a space. Now, this is what you fill in, okay? You fill in the second letter, which is F. I'm going to fill in this. I'm going to fill in this, okay? Now, the last part says, okay, all right, what do you want to calculate, okay? If it's just x, okay, I probably should have put this with a 2. All right, if it's just x, I actually have to do some operations. For this, what I can do, all right, I'm going to put 2 in, okay, all right, so I'm going to do 2, arrow for x, hit execute, so that saves 2, and then I'm going to type in 4x, okay, parentheses squared, minus 4. I'm going to type it in just like I see it, and hit execute, and it will give me the answer of 56, all right. Now this problem here, okay, all right, this problem right here, a little bit different, okay? That means multiplication, okay? So the G function here is x squared minus x, and the F function is 4x. So I'm going to multiply here, okay? All this means, I'm going to multiply that, that's going to be 4x cubed minus 4x squared. Since there's an x there, I leave it, all right? G of k of x, so I'm going to start with G. Okay, so the G function here is x squared minus x. So once again, I'm going to put a set of parentheses here where x was. Now, I'm going to fill in the k function. Okay, what's my k function? Square root of x plus 3 for each one. Now, the difference here is there's just an x, so I'm going to perform the operations. Squaring a square root gets rid of that, and this is just going to be left as this. Okay? All right, extend that over there. I cannot combine these because that's underneath there. All right, moving on. F minus h. Okay, so what that means, I'm going to start with the F function. Okay, which is 4x. Okay, so 4x minus the h function. All right, the h function is 2x minus 1. Now, here's what this means. This means change the signs of the second one, okay? So what I'm going to do, instead of 2x, it's going to be negative 2x. Instead of negative 1, it's going to be positive 1. I bring down this 4x. Now I combine these. That's going to be 2x plus 1, all right? And that's all I can do there. H of g of x. So the h function is 2x minus 1. So I'm just going to get rid of the x. Now I'm going to fill in the g function. G function is x squared minus x, okay? Since there's an x here, I'm just going to distribute that and see if I can combine like terms, which that's all I can do, okay? All right, k of g of 1/2. So I'm going to start with the k function. Sorry for all the scrolling. All right, so I'm going to start with the k function, which is square root of x plus 3. All right, square root plus 3. All right, I'm going to fill in the g function. Okay? The g function here is x squared minus x. Okay? Now, how would I would combine the things that I can in here. Okay? Well, actually, I don't even need to do that. I'm just going to type everything in with parentheses. Okay? Here's how I'm going to do that. Since it's 1/2, okay, I'm going to do 1/2. Okay, that's how you do a fraction. Arrow for x. Okay? Now, I'm going to type this in. Square root, be very careful. You need to put parentheses around all the stuff in the square root. That way, you know that it's there. All right? And then I'm going to do the extra set of parentheses around x squared minus x. All right? Plus 3. And I'm going to close it. That tells that whole thing. All right? Boom. That's what my answer is. 1.65. Okay? 1.65 would be my answer. All right? Going on. G of x. Okay? All right? G is x squared minus x. So I'm going to start with x squared minus x. And that's what I'm going to fill in. All right? All right? X squared minus x squared minus x. Now, what this does is change these signs. So I got negative x squared plus x. What I do with this is I'm going to do some boxes. Okay? This means write twice. Okay? So x squared times x squared would be x to the 4th. That would be negative x cubed. This would be negative x cubed. This would be positive x squared. So what I'm going to do is I'm going to combine all those. So I got x to the 4th, negative x cubed, so that's negative 1. Okay? Negative 1 minus 1, which is negative 2. All right? It's going to be negative 2, so negative 2x cubed. Okay? X squared. Positive x squared, negative x squared. So those are going to cancel each other out. And then I got a plus x there. All right? So that's going to be my final answer. Okay? All right, moving on. Number 9. Find the inverses. Okay? Given terms of x. So here's the deal. All right? What we want to look at is something inside the function or outside the function. And we're going to change signs as we go. Okay, so here's what I mean. I can just do y equals. So 5 is considered outside the function. Okay? All right. Now it's going to be considered inside the function. All right. So x minus 5. All right. It's 4 times the outside. So now it's going to be divided by 4 in the inside. Okay. For those of you that like the longer algebra way, the simple way, another way to do it is switching x and y. All right. Solving for y, so I would subtract 5. So that's x minus 5 equals 4y. And then dividing the whole thing by 4. So if you see, it's the same thing. So this is considered outside. This is considered multiply by outside. Okay? So the opposites of all of those are 5 now. 5 goes on the inside and changes sign. So now it's inside the parentheses, if you will. 4, instead of being multiplied by 4 on the outside, it's divided by 4 on the inside. Okay? Let's go to 10. Okay? All right, that's going to be y equals. All right? Instead of 1 being on the outside, okay? Well, first of all, before I get to that, if this is squared, I'm now going to change it to square root. Okay? So we want to do opposite functions as well. All right? I don't know if you can see that. We want to do opposite functions. Opposite functions. Okay? All right? So instead of squared, I'm going square root. 1's not going to be outside, it's going to be inside, and it's going to change sign. Okay? And that's all you have to do for that. Once again, if you wanted to see that, all right, if I switched x and y, all right, that's x minus 1, and then the square root, you end up with the same thing. All right? Okay? So I'm not going to keep that in there. All right? There's a faster way to do it. All right? A more accurate way. All right? Let's go on to number 11. Okay? Now, since that's square root, I'm going to change this to squared. Okay? Now, 4 is on the outside. It's going to come in and it will be on the inside. Negative 3 is on the inside, it's going to come and be on the outside. Okay? Number 12. All right? All right, that's square root, so I'm going to use squared again. Okay? 5 is on the outside, it's now going to come in on the inside and be changed to be negative. 2 is being multiplied by the outside, so will be divided by the inside. Okay? You can, once again, you can use all those operations and see how that works out. Okay? All right, moving on. Okay? Now, when you get to log, we consider this part and this part the inside. So the blue is the inside part of the function. All right? In exponentials, this part is considered the inside of the function. These parts here, okay, the green are considered outside the function. All right? You will always change between log and exponential. They go back and forth. All right? In the red here, these are considered the bases. Now that's a base of 10 when you don't see one. All right? So the red is considered the base. All right? So how should you do this? All right? So that's going to change to y equals, my base is now going to be exponential of 7. All right? All right, I'm going to keep the x here. All right? 3 is located on the outside, so it's now going to go on the inside and change sign. That's all you have to do with that. Okay? 14. Okay? It's going to be y equals 10. All right? All right? Now, what this is going to be here, all right, minus 5 on the inside is now going to become plus 5 on the outside. Now, the 2 is multiplied by x on the inside, so it's now going to be divided by 2 by the whole thing on the outside. Okay? This is x plus 1. Okay? This is x plus 1. So I'm going to turn that into y equals, okay, log a base of 6. Now, that's plus 1 on the inside. Now will be minus 1 on the outside. Okay? On this one, I'm going to turn this to log of base 3. The plus 7 is on the outside, but now will be minus 7 on the inside. Minus 2 on the inside, but now will be plus 2 on the outside. So you just take some practice. Okay? Inside, okay, that's going to be inside, now becomes opposite outside. Outside becomes opposite inside. It's the fastest way, the most accurate way to do that. Use composition to determine if they're inverses. Okay, so here's what they want you to do. They want you to do f of g of x. Okay, so I want to start with f. All right, I want to put a set of parentheses where x is. All right, so I got square root of x plus 2 minus 3 squared. Okay, all right, plus 3. All right, now the goal is, in order for this to be an inverse, that has to happen. And as you can see here, this is going to get very complicated. This is not clean, so this answer would be no. All right? Same thing over here. F of g of x. So what I would start with is 3 parentheses plus 4. All right? Now I'm going to put 1/3 x minus 4/3. Now if I multiply that, that's going to be 1x minus 4 plus 4, so I get 1x. So that is true. Okay? So if that equals that, then that is true. All right? The other simple thing is to check that g of f of x equals x. All right? So that's 1/3. All right? Minus 4/3. So if I put 3x plus 4 in there and multiply, that's 1x plus 4/3 minus 4/3. Once again, I get 1x. So this answer is yes. This answer is no. All right? Moving on. All right? Write whether this is true. This first one's true. The x and y's flip. So yes, that's true. F and x are the inverse. This means inverse, by the way. This means inverse. Our reflections here. That's true. All right? The inverse is always a function. That's not true. We just went over that. That's no. Well, let's not use no. Let's use false. Okay? False, false. The domain is this, all right, of the regular, then of the inverse. No. What this would be, this is what this would be the range, okay? The range would be y is greater than or equal to 3. This one would be true if it equaled x, all right? And this one just not all the time, all right? 20, determine whether they're inverse of each other. Here's how you do that. Take a couple points. Let's say this is 0, negative 2. Then what should happen is you should be able to switch them, and it would be negative 2, 0. Well, negative 2, 0 is here. That's the other function, so that's no. The points didn't flip, okay? All right? Okay. So if they do f of negative x, that should equal 6, not 10. They equal the same number, okay? All right, equals the same number. All right? Graph and label. So here's what you do. All right? Graph, I don't know, a couple of points. All right? Let's say for 2x plus 4, we're going to use negative 2, negative 1, 1, and 2. All right? So if I put that in there, that would be 0. All right? That would be 2. All right? That would be 6. All right? That would be 8. So negative 2, 0. All right? Negative 1, 2. All right? 1, 6. 2, 3, 4, 5, 6. And 2, 8. 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that would be my line. Okay? The inverse, all right? The inverse, you switch all of the x's and y's. So what I would do is it would be 0, negative 2, okay, which would be right here. All right? It would be 2, negative 1, which would be right here. It would be 6, 1, all right? 1, 2, 3, 4, 5, 6. Wait a second, that's not right. Hold on 1 second. All right, 1, 1, 6. Okay, so now it's 6 to the right and 1 up. Okay, and then 8, 2. So that's 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Okay. All right, wait, there's something wrong right here. Oh, that should be 0, negative 2. I graphed the wrong place. That's right. That's not right. Whoops, hold on. Sorry. Even the teacher makes mistakes sometimes. 0, negative 2 would be here. Sorry about that. So that would be the inverse. Okay? All right, that would be the inverse. 0, negative 2. I graphed that in the wrong place. All right, negative 2, 0. All right, I didn't graph the first point. Okay. All right, moving on. Given the graph below, graph on the same axis once again. Okay, that point right there would be 1, 2, 3, 4. That would be 4, negative 1. All right, that would be 3, 0. This point here. Okay, and that would be 0, 1. So I'm going to use these. Okay, so the inverse would be negative 1, 4, 6, 3, 1, 0. So negative 1, 4, 1. So my anchor point is still negative 1, 4, 1, 2, 3, 1, 2, 3, and 4. Okay, 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, and 1, 0. Okay, 1, 0. No, oops, that's not. I'm sorry, hold on. That's not 6, 3. Sloppy handwriting. Okay, that's 4, negative 1. That's 3, 0. That's 0, 1. So I should have negative 1, 4, 0, 3, and 1, 0. Okay, so negative 1, 1, 2, 3, 4, 0, 3, 1, 2, 3, and 1, 0. Okay, so what that should do is go like that. Okay, and let's move on. Okay, rewriting the base. Okay, here's the idea behind this. Very simple. Okay, all right, same thing like the other one. The base of the exponential will be 17. Okay, same base, so keep base. All right, simple to remember. Doesn't equal the same thing. Hopefully this can come down so you can see it a little better. Okay, all right. So So what this is going to be, I'll move this down as far as I can. All right, so 17, all right, on your paper, it equals 2. It won't equal 2 anymore. It will equal 289. So there's 3 parts, 1, 2, and 3. Okay? Keep the base, can't equal the same thing, so it's got to become an exponent. So for this one, all right, the base is 5, I'm going to keep that. It's no longer going to equal negative 123. It's going to equal that, and negative 3 becomes the exponent. All right, we rewrite these in log forms. That's the base. So log of y. No longer is going to equal 144. It's going to equal x. The 144 goes in this spot. Okay? All right? On this one, all right, it would be log of 196. It's no longer going to equal 1 over 14. It's going to equal negative 1/2. Okay? All right? Our graphs, all right, 3 to the x power. All right? Very simply, our anchor point is going to be at 0, 0. Okay? Anchor point will be at 0, 0. We have a horizontal asymptote through that anchor point. Okay? Very simply, we're going to use these. Okay? 0, 1. Okay? 1. All right? So I'm putting that into 3 to the x. 3 to the 0 power, just to reinforce. Okay? 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. Okay? So 1, 3, all right, 2, and 9. Okay? So from my anchor point, what I'm going to do is I'm going to go 0 over 1 up, 1 over 1, 2, 3 up, and 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's what this looks like. Okay? Okay? Comes down like this. Whoops, not very good there. Okay? Let me go from this angle. It approaches this asymptote, and then goes straight up through there. Okay? Now, what you have to look at is what's the base here? Okay? All right? What's the base here? All right? So the base here is 2. Now, what I want to graph is I actually want to get the points for that. Okay? Which that x and y, 0, 1, and 2, for 2 to the x. Okay? All right? Would be 2 to the 0, 2 to the first, 2 squared. Okay? All right, so that's 1, 2, and 4. All right? 1, 2, and 4. Now, somebody's going to say, well, Mr. Evans, this is a log. Yeah, when you do this, it's the inverse. So we're going to switch everything. So we're going 1, 0. Okay? We're going 2, 1. We're going 4, 2. Now, my anchor's still at 0, 0. But now I'm going to have a vertical asymptote through there. All right, so 1, 0, 1, 0, 2, 1, and 4, 2. 1, 2, 3, 4, 1, 2. And once again, it approaches the asymptote, all right, and then, okay, goes that way, all right. Now, my anchor point is just changed for this. It's going to be 1, 0. So I'd be right here. I'm still going to use 0, 1, and 2. It's going to be 1, 2 to the first is 2, 2 squared is 4. Okay? I am going to put an asymptote through that. 0, 1, 1, 2. Alright? 2, 4. 2 over 1, 2, 3, 4 up. It approaches that line. Okay, it goes vertical through that. I've changed this on your sample test. Okay? I've changed this on your sample test. Now, forgive me if I'm wrong on this, okay? I think I changed it to x plus 1 minus 2. If I change, that's a little bit off. Just use this example to help you. So let's say my anchor point here is going to be -1, -2. So -1, -2. So what I'm going to do with that is I'm going to draw my asymptote through that like that. I'm going to look at this base. All right? So I'm going to use 3 to the x to do that. So 0, 1, 2. Okay, that's 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. Okay, so from here I'm going to go 0, 1. 1 to the right. Oh, whoops, I'm sorry. I didn't show you the inverse yet. Okay, so when the inverse comes, that's going to be 1, 0, 3, 1, 9, 2. So 1, 0, 1, 2, 3, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. Okay. And that does that. Okay. That's 31. All right, 32. I got to make sure I graph these. Okay. What I'm going to do on this one, okay, I'm going to move this down. All right. I'm going to graph 3 to the x. 0, 1, 2. All right, that's going to be 1, 3, and 9. Okay. Now my anchor here is 0, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 9. All right. Now, since I have that negative here, I'm going to multiply all these by negative 1. So that's negative 1, negative 3, negative 9. All right. So I graph 0, negative 1. 1 to the right. Okay. 1, 2, 3 down. And then this is going to be 2 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is what this is going to be. Okay. Now, the zeros. Okay. Where does it cross the x-axis? 2, 0. So x equals 2. That would be 2 comma 0. Okay. The y-intercept, that's right here. That's at 0, 8. Very important. These, no asymptote. Do not include the asymptote in that. It's not involved with that. Now, we have a horizontal asymptote, and just to let you know, when you have a horizontal asymptote, that's a y equals equation of our anchor. So that's going to be y equals 9. Okay? Y equals 9. Make sure you write the y equals. You will lose points if you do not. So this is done here. Okay? Increasing. Now, how we label this. This is still considered a right arrow that is going down. This is considered a left arrow, negative infinity. Now, where it levels off at 9. Okay? So this is, I don't know if you can see that, negative infinity, 9. So where it levels out at the asymptote, this is only for asymptotes, that coordinate wouldn't be positive infinity. It's going to be 9. So we're going to still start from here. So this is decreasing the whole way. So this is done. Okay? This is decreasing from negative infinity to infinity. Okay? And behaviors. X approaches infinity. Okay? Y approaches negative infinity. As x approaches negative infinity. Okay? All right? Y approaches 9, not infinity. Okay? The domain. Okay? Smallest x value. Okay? Smallest x value here is negative infinity. Biggest is positive. So the domain is going to be all real numbers. Okay? For the range, my smallest y value is negative infinity. My biggest y value is 9. Okay? I don't put a line underneath that because the asymptote includes that. So that's going to be y is less than 9. Okay? Alright, let's go on to the log equation over here. Okay? My anchor point is negative 3, negative 2. 1, 2, 3, 1, 2. Okay? I'm going to start out by figuring out what 3 to the x is. So that's 1, 3, and 9. But since I'm doing the inverse, I'm going to do 1, 0, 3, 1, 9, 2. Alright? So from here, I'm going 1, 0, 1, 2, 3, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2. Okay, so here's what I got. Alright? My zeros. 1, 2, 3, 4, 5, 6. It's going to be x equals 6 and 6 comma 0. My y-intercept is 0, negative 1. Okay? I've got a vertical asymptote. Now, when you have a vertical asymptote, it's going to be an x equals of the anchor point. So my anchor point here was negative 3, so this is going to be x equals negative 3. This is going to be none. Okay? Now, let's label the arrows. This is a right arrow that is going up. Okay? Now, here's a little bit different of a concept. Since this is leveling here, okay, it's leveling at negative 3, okay? It's going to be a negative infinity because it's going to go straight down. It's leveling this way, not this way, okay? So when I do increasing, I'm going to start from here, which is negative infinity 3, okay? Negative 3 to infinity. It's not decreasing at all, okay? My end behavior, okay? As x approaches infinity, y approaches positive. As x approaches negative infinity, now I don't have that, so it's not going to be anything. As x approaches negative 3, y will approach negative infinity. The domain, smallest x value is negative 3, biggest x value is infinity. So I would have x is greater than negative 3. That's my domain. My range, my smallest y value is negative infinity. My biggest one is positive, so range is all real numbers. As you can see, domain and range switch which ones are all real numbers. These inequalities involve their asymptotes. If you want to look at it this way, if it's below the asymptote, the range will be less than. If it's to the right of the asymptote, it will be greater than. That's another way to look at it. Write an equation with a function that has a range of y is less than 2. So let's look at this. Which one had a range that had y? Well, that's going to be an exponential. Okay? So here's what I'm going to do. All right? All right? I know my anchor, which would be 0, 2 in this situation, has to match up there. Now, how would it go below? You would put negative. If it were y is greater than 2, then you would just have a simple one like that. Okay? Because that changes the angle. All right, 35, this is a review question. All right, make sure you fill in this dot, which is negative 4, negative 2. Make sure you label this arrow, which is positive, positive. Okay? The domain, smallest x value is negative 4. Biggest is infinity. So that's my domain, which is x is greater or equal to negative 4. The smallest y value is negative 2. The biggest y value is infinity. That's going to be y is greater or equal to 2. Okay? That crosses at negative 3, so x equals negative 3. That's negative 3, 0. This crosses at 2, so that's 0, 2. All right, increasing interval.